Okay, for problem 51, we have a sample where we have a diver. He springs upwards with an initial velocity of 1.8 meters per second from a 3-meter board. So if we kind of draw this out, we have our diver. He's 3 meters above the water, and he is going to bounce up with a velocity of 1.8 meters per second. And, he's going to spring down and eventually hit the water. And the question for part A is asking what velocity does he hit the water with. So we're going to try to figure out our three variables. Two of them are drawn in the picture. The last one is automatically assumed because we're assuming no air resistance. So our V initial is 1.8 meters per second. Our acceleration is negative 9.81 meters per second squared because it's a free fall problem. And our displacement is negative 3 meters because remember displacement is just dependent on from where you start to where you end. So it doesn't matter that he jumped off the board and got really high and then came back down. So using these three variables, we can calculate his V final. The equation we use is the V final squared equals V initial squared plus 2ax equation. We plug in our variables, and we calculate V final by taking the square root of V initial squared plus 2ax, and we get 7.88 meters per second. Now, remember that every time we take the square root, there's actually two possible answers. It could actually be plus or minus 7.88 meters per second, so we have to look at the problem. He's about to hit the water, he's falling, so his velocity should be pointing down, so our complete answer is negative 7.88 meters per second. Now for part B, they want to know what is his maximum height, like how high does he get? So if we marked it right here with an X on B, so for maximum height, there's actually something we know when we calculate the maximum height. When you find the maximum height of something, you are reaching a point. Let me go back here. Right here, these two arrows, right before the maximum point, you're not really going up anymore. You haven't exactly started going down. You actually just got to your maximum point, which is where your velocity is 0. It's right at the moment where you have stopped going up and are right about to go down. So, got a little ahead of myself. So our final velocity at the maximum point is going to be 0 meters per second. And then our initial velocity is still 1.8 meters per second positive. Our acceleration, because it's still a free fall problem, is still 9.81 meters per second squared. So using these three values, we can calculate our displacement. Now, I'm going to call it delta x, even though sometimes I normally just call it x, because we'll see what it means in a moment. So if we try to calculate the displacement, we'll use the Vf squared equals Vi squared plus 2ax equation again. This time we'll solve for a delta x. So we plug in the values we know. We isolate delta x, and then we find that delta x is 0.17, this thing keeps skipping, 0.17 meters. Now that is our displacement. So to find our actual height, we got to look at where we started. The actual swimmer started 3 meters above the ground, so if his displacement is positive 0.17, his actual final position will actually be 3.17 meters positive, or 3.2 if you want to round like the back of the book did.